Of the broken ones.
The updated version.
The updated version. Yeah.
The one that doesn't catch on fire?
Right.
Okay. I mean, that's an important thing to do.
So that one could catch on fire.
Get the non-catch on fire one. Yeah, you're right. You should stay away from it.
If anything, it's
Still catch on fire.
Okay, see, John, you need to sit closer to him and have your phone ready, like on the video recorder, so when it catches fire, you can take a video.
You wouldn't try to put it out?
Are you serious? You're gonna try and put out a lithium-ion battery fire?
You're right. Stupid me.
It only lasts like 30 seconds anyways.
Yeah, I mean, we'll just watch you for a while and then leave.
He's in a new building anyway, right?
We're getting a new building.
Exactly.
Let's see. When do you guys graduate?
It'll be our last year.
Your last year, we'll have the new building, right?
Yeah. Right.
Okay. Oh, I was gonna show another picture. Since,
The picture of your ID.
well, no, you don't want my ID. So I think Mason, you weren't here, were you? Do you get that joke? Do you understand the reference?
About eating soup with a fork. Oh, I don't know who makes more sense.
Okay, I thought you were old, so you would get it, but apparently not. Oh my goodness. It was a song in the 90s.
It's like 10,000 screws.
10,000 spoons when all you need is a knife.
Yeah, that's
Ironic. We hear it. I don't believe you that this is song.
You don't believe me?
Nope. It's like
It's like 10,000 spoons when all you need is a knife. God. But I had a soup. Oh, you guys are just make me
I would
feel
say
home.
fork there, but
I know.
I don't know why.
Spoons and knives, though, are not very useful.
Dude,
Mason, I thought you were going to bail me out and be the second student in my two classes.
Who was the first? I'm curious.
I'm sorry.
It was Zane. Yeah, it's either Zane or Kyle. I can't remember. Yeah, Zane.
He has a lot of random stuff.
Okay. So, last time... Oh, so I was looking. Apparently, I'm also old in another sense. Remember I told you guys that you couldn't like allocate your thing on the stack, and I found out like I guess that's a thing now in C99. So I guess I'm just old and didn't realize that you could do it in C99. I think it's a Visual Studio thing too. You can't do it, but oh, I guess I'll count it as good.
We get bonus points if we did skip, but
Do you get bonus points if you did it the right way? No.
do it the other way. What do you want?
No, I didn't say it exactly 100% specifically. So.
do we have a completely full schedule today? Because I have a Linux question that would kind of pertain to this class.
I am always open to doing other things. So what is your Linux
do it.
question?
Okay, so on the Raspberry Pi, I've been messing around with that, and I'm getting into aliases. And for whatever reason, I'm not sure if it's because it's Debian based. The file is you would do sudo nano /bash _ aliases. But on my Linux, I'm running Fedora 24. It's bash rc. So do you have any idea why that is?
So why is it bash rc versus bash aliases?
Yeah.
So I've really never heard of bash aliases per se, but
Okay.
I'm guessing it's a place just for aliases. So,
It's
Okay.
Linux. You could do it on the SSH or the CS server to help you out.
yeah, so what happens is, so both of these are going to do similar things. So an alias allows you to say like Bob and it runs ls or something, right? So the bash RC is the RC stands for run configuration.
Okay.
So whenever you start a new bash shell, what it's going to do is it's going to look in a couple of different places. I believe one of them is in general /etc/bash profile, I think. So that's like system-wide configuration. So if you want to make it so that everybody, when they run GCC, it does something, uses a particular version. Like you can run GCC 3, you can run GCC 4. So you can set global permissions for things, and then each user is allowed a .bashrc or local version. So like, for example, in mine I have done things like, set where Java is, set my path, set that I want colors in my command line, so CLI color equals 1. An interesting one is my, let's see if I can find it. Oh, so there's these like PS1, PS2, PS3. So let's define what kind of, when I'm at my prompt, you notice how it says like, let's see. You notice how it says Miller at, and then CS Linux, tilde, right? So it shows me like my path, and then I have it do a new line, which most of you guys, it doesn't do a new line. Well, that's because I defined that in here as the PS1 variable. So every time I log into bash, it reads that PS1 variable, and then bash by default says, oh, you have a PS1 variable defined. I'm going to make it so that it starts off blue, right? So you like tell what color, so $sign, and then brackets blue, and then /u is for username, and then I change it to purple, right? And put the @ sign, and change it to red, and do the host, the /h. The W is the working directory, and then I put a carriage return and new line, and then a $sign, and then I change it to NC is no color, so black, or the default, right? So that's why my prompt looks like that. So all of these settings that you do, like updating your path so you can find different programs, so if you build your own program. For example, I always have a folder called bin or .bin. I actually use .bin because you can call it whatever you want, but when I do my assembly class, we have a folder that's called bin that gets extracted, and I want that to be default so I understand if it still works or not. So I add that to my path so I can have my own scripts that run. So for example, when I grade your homework, so I have an automated script that goes through and just runs your program using a standard input, does a diff on them, so it'll compare the two, so I can see, given your program on a certain input and my program on a certain input, did you give me the same output for some of the homework assignments that I give? So that's kind of what it does. So it's just a Debian thing that it has for those aliases, and they're just like shortcuts. So you can say, we can make one that every time I say GCC, it actually does GCC ---- std C99. Right? So we could do that so that way I wouldn't have to type that every time, but that's okay. It's good for me to learn. So that's kind of what that is. Let me see if I can find the global one. Yeah, so this is the system-wide one, and like OS 10 has a different location for it, so. Other Linux questions?
Do you have to be a super user to run it?
So you do have to be a super user to run it. You don't have to be a super user to look at the bash RC global one, but you have to be a super user in order to modify it.
Okay.
And then your local one, you just make it yourself. Type in
Yeah.
all the code that you want. I think if everybody logs in, I think you get a by default. You get a bash RC file, so it creates one by default for every new user that we have, I believe. So, good question. Other Linux questions? I like Linux questions because, in general, I like Linux.
Just because, why not? So, if I have one alias and I wanted to do multiple actions, like go to this directory and then run a file, you would use the semicolon, right?
So semicolon will end a statement.
Okay.
Yes.
Okay.
But in general, so I wouldn't make that an alias. I'd make that a shell script.
Okay.
And then, so like, for example, my bin directory. Right, I have a bunch of different shell scripts. So that one does something, right?
Yeah.
Does object dump on the file that I give it. And so you can put in there as many programs as you want, and you can write a full shell script for any of those. So that's what I recommend doing. Like you write your own personal ones and you put them in there.
Yeah.
Just because then you're not sort of confusing an alias, which is like renaming a program versus like, I want to do a bunch of things.
Okay.
And here you can do error checking and, ifs and things like that. And it's
Yeah.
just sort of cleaner.
That makes sense. So, thank you.
Yeah. Any other Linux questions or questions in general? Why doesn't Donald Trump pay taxes?
Why isn't Hillary in jail yet?
Why isn't Hillary in jail? Well, first of all, even if they found that, like, she shouldn't have been running email, she wouldn't be in jail yet. So, it takes a while.
Yeah.
I'm sure we're going to hear about that if she wins for the next 4 years. So, don't worry. We'll get plenty of that.
I do have a question.
Okay.
Why do you use that pointer arrow instead of the asterisk for example, foo size, foo pointing the size?
Why do we use the arrow?
Asterisk instead.
Yeah.
And,
So-
asterisk and then point. I mean foo dot size with the asterisk in front of foo. Because there's apparently one other way of doing it. Which is, why do you use that way instead?
Okay, so let me show you. You're asking why do I use foo arrow size?
Yeah, the arrow.
Like on this line? Or down here? Does it matter?
In general.
Okay. So let me show you the other way you can do this, right? So the other way is foo is a pointer. So I'm going to get the value of the pointer, and then I can call the dot size. So those are equivalent. But let me ask you which one you want to type. All right, so they added the arrow operator because the arrow operator is easier to type than to dereference the foo pointer and then use the dot method. So in like Java, right, you use the dot method when you have an object. So I could do either one. But to me, and for most people, right, using the arrow operator is a little bit easier to understand. Like, I'm going to dereference this pointer, and then I want to access a certain record within this structure. Right, and the way that, when you think about a structure, right, it is just a list of data items that are inside of an object, or they're data that's pointed to by that pointer. So it's just easier. That's why we use arrow as opposed to using the dereference and then the dot.
Now, if we were to scan into size, would we have to go foo arrow address size?
Yes.
Okay.
And so, yeah.
How's
So
it different than just declaring it?
how is that different than just
Why can we just put 10 in size like that, but when we scan it, we'd have to say at ampersand sign size.
So why do we have to use ampersand size?
Right.
So what happens is, so within this function, and so we're talking about stacks. So actually, when your program is running, it's actually using the stack to store what are called variables.
Okay.
So the stack is this structure that you'll learn about in computer organization that allows us to sort of keep track of what function are we in and what function did we previously call. The problem is that when you call a new function, every parameter that you call is going to be a copy. So let's suppose I pass a copy of size. Well, what is the value of size? Here it's 10, right? So I have a copy of 10, and I'm doing a scanf, and I overwrite that and say it's 20, but it's a copy of the original, right? So now I've changed the copy, but I haven't actually changed what I wanted to. So because I wanted to change what was in the previous, what we call stack frame, I need to pass it the address of the thing that I want to change, otherwise it's not going to work. Now for foo, it's even more complex because foo is a pointer that is on the heap, right? So when we talk about, I mean, I can draw a picture of this because I probably draw it about 1,000 times a semester, but, well, not that many, but several. So when our program is running, we can conceptually, I mean, actually it's not this way it used to be, but it sort of has morphed a little bit when you get into operating systems, you learn about virtual memory and stuff. But we had one segment that was called the text segment. We have this other structure called the stack, and the stack grows this way. And then we have this area in between called the heap. So the stack keeps track of where I am, what local variables I have. The heap is memory that is going to be there for a long time, right? So it's memory that is not, the stack grows, and as it goes back up, right, you lose this memory. And we'll talk about it in organization. So when you do malloc, it actually allocates a little block here in the heap. And then inside that block, we had a data structure. So let's say it had 3 members. So each one of those has its own address within that block within the heap. So when we look at foo, right? Foo is a pointer that points to that location in memory. And it actually points, the address of foo is the same as the address of size, right? Because size is at the beginning of that data structure. So if I were to draw my data structure really in memory, we would have size, starts at offset 0 and has 4 bytes. And then our next data item, top. And then our next item is array. So if foo, F-O-O, has the address of 1,000, size also has the address of 1,000, top is 1,000 plus 4, or 1,004, and array is 1,008, and then array is a pointer that's going to point to some more data that's in the heap, right? And it might have it's going to have a different address. It's going to point to like 2,000 or something like that, right? And so then to get that, I have to dereference that and get the data at 2,000, not the actual number 2,000. Right, so the reason why we have to put the ampersand is because we need to get the address of that thing, so that way when you're in the function, it says, oh, I have an address. I can now change the data at that address instead of changing the copy. So I have a copy of the address or a copy of the pointer versus having a copy of the actual data. Right, and so when you're modifying, that's why you need it. Now like printf, all it needs is the value, so you can just pass it the value because it's just printing it, it's not trying to modify it. So if you print a copy of the data, right, it's okay. Other questions?
So we're looking at stacks. Now is stack just a different implementation? Like, to me, it looks like the same thing as an array, just would change like variable names. Like instead of like current, we're saying top.
Mm-hmm.
Does that make sense? So like you can actually read it the opposite way, and we're just printing it backwards, are we not?
So you're saying, what's the difference between a stack and an array?
Well, I mean, I get it, but I feel like we're doing like.
Okay. Yeah. So what we're actually saying here is that we're implementing a stack using an array.
Okay.
Right. We could also implement the stack using a linked list. Right. So if we had top was a pointer that pointed to the top of our stack, we add some element, and then if we push something else onto the stack, so let's say this is element 1, then what we need to do is element 1 is going to have a, well, we'll say we'll push element 2 onto the stack, right? So we're going to want top to point to 2 and then 2 to point to 1, right? So what we're really saying is we're implementing a stack and it's backed by an array. So that's kind of the difference between how we implement it and what it actually logically does, right? So logically, we always do things like push, right? We push something onto the stack. Or now it's on top, and when I do a pop, I will get it off instead of the previous thing. And we have the last one in is the first one out, so the LIFO, right?
Well, like last class, I was just confused, like, how are they different? But like,
Yeah. So an array, the actual definition of an array is it's just a sequence of bytes that are allocated consecutively.
Right. And they still, like the index grows, just like top will grow.
Mm-hmm.
So like,
yeah. So they are similar, but again, they're a little bit different, right? There's benefits to doing this version versus the one we're doing. So can anybody think of the benefit of using dynamically allocated memory versus using an array?
You won't have to copy it if you fill up.
We don't have to copy it if we fill it up. Or let's say I allocate 200 megabytes and I only use 2 things on it. So what is the benefit of dynamically allocating it?
get rid of the excess.
Or you won't allocate extra, right?
Yeah.
What is the downside of using dynamically allocated?
You have to traverse it to find things.
Well, in a stack, we only ever push things or pop things from the top.
Oh.
But if we think about how much, let's say if we dynamically allocated, we have to create a structure for that, right? And let's say the structure has one element, one member that is the data. Let's say that's an int, right? It takes up 4 bytes. What is the other thing that we need in if we're going to dynamically allocate it?
Pointer to the next.
A pointer. So let's say that that's 64-bit, so that's 8 bytes. So for every element that I store, I use 12 bytes of storage, right, 8 plus 4, but I only have 4 bytes of data, right? So I'm less efficient with my data because, in that sense, because 2/3 of it is the pointers, right, that we're consuming. So every time you implement something like that, you got to think, well, what is the downside to doing this, right? I'm taking up, for every byte of data I'm going to store, I'm taking up more space, right? But I'm only using the space I need, so if I need only 10 things, right, I only allocate 10 things. And if I need 2,000, I allocate 2,000. I like questions. It means you guys are thinking. And that's what I'm here to do, right? Make you think or stay awake so you don't get hit by a tennis ball. Oh,
I knew it.
good catch. Good catch. Just don't knock my coffee over because then I'll be upset.
That's a challenge.
Challenge accepted.
It's
All right. So last time, right, we implemented the push, right? So we had the character push and grow. We had the stack pointer, so it points to our stack that we're going to implement. Right, so one of the weird things is that when we're dealing just in C, right, we have this notion that, like, we don't have our methods that are associated with our regular classes, right? So this is sort of different mentality than, like, when you guys are used to doing stuff in Java, right? Java is nice, I think, right? It has this ability to sort of bind, this method is just for this type of thing that I want to do, right? This type of object. C, right, it's kind of glopped on top, right? It's not great. Right? C++ is a little bit better. All right, so implemented push. What else do we need to implement? We have 2 operations we have to do. What? Pop. Right? So what do we think that pop is going to return?
first element in the list.
And what type is our element in our list?
Int. Just kidding, a character.
Just kidding. Character. You're right. Okay, and what else? What is my parameter that I need in order to pop something off? And what's it called? What type is it? So how do we get the thing on the top? Do we need some sort of error checking? Spencer says yes. Who wants to tell me what we should check? Well, how do I know if it's empty or not? What? Top should be different than 0. So when we started, what was the number for top? We said top was 0, right? So what? If top is 0, we want to do something, right? Equals, I'll just say 0. Right, so we'll assume that people don't want to put 0 on here, right? You can argue whether or not that is a good assumption or bad. Yes?
I just want to clarify. So we have this one set as char pop because the stack, not the stack, it's a character, right?
Mm-hmm.
Okay, just make.
Yeah, so if we look at the if we had used integers, right, this would be an int.
Okay.
Right, so here we defined that we were going to store one character, right, in our stack, right? But yeah, if we had picked a different type, then we would use that respective type. Okay, so if top is 0, right, I'll just put squirrel.
Yeah.
So actually, I set the default so that way we can just like not do anything but say that this is a bad state, right? Like if we were in Java, what would you do? What would be a method of handling this fact that we have an error? Throw an exception, right? So in general, that's the way Java handles it, and we don't have that ability here, right? So a way to handle that would be to return a different type of data structure, which is keeps track of information like error handling. So you might call it result, which I've done a lot, right? And you have part of it is what is the result status? Like status equals okay. All right, great, things are fine, right? Here we're saying that 0 is not a valid thing for us to put in on the stack. You can argue whether or not that would be the case or not, but so that's what we're assuming. So yeah, in reality, we would not do this type of thing. So if top is not equal to 0, what do we need to do? Okay, so we need to move, right? So if we look at the operations, we're just going to invert them, right? So do them in the opposite order. So we're going to decrement top. So top is like, where does my next new thing go? Right, so we're going to decrement that. So how would we decrement that?
Well, what is one ground item before you decrement it? What's the return value?
Well, if you look at how we did it before, right? So when top was 0, right, we set top was still 0. So we accessed the array at 0 and set it to the thing we're going to put on, and then we incremented it. So yeah, we're going to do it the opposite way. You're right to think about it, but in this case, yeah, we're going to actually access the thing. We're going to decrement top first and then access the thing at that location, because when we go to push something on, it's going to point to that new thing. And we'll make sure it works. But so, how do we decrement top?
My stack arrow top minus minus. You need a my stack arrow top for your instant too.
Oh, good catch. See, I forget. When you're in Java, you just have like member variables, and you just use them. My stack arrow top minus minus, and then what do we want here?
Result is equal to my stack array.
Arrow. Yeah, use all the words. Right? So go ahead and set result equal to grabbing the array, right? So getting the address of that, and then getting the index that we want, and getting the value from that. Set it equal to result, and then what do I need at the end?
Return result. So what would you do for the, like if it does equal 0 in this case, what would you do for an error?
What would you do for what?
For an error.
Right, so here, if we're assuming that if result is equal to 0, it's an error, right? You would have to check for that when you are calling that. Just like when we did push, right, we returned a bool. So every time we do a push, we should actually do a check and make sure. Okay, if it's equal to 0, right, or if it's equal to false, in the case of push, then we want to do something. So here, in a second, we'll try and implement it the error handling way. So we'll go ahead and do that. But I want to we'll just run it, make sure it works, right? Anybody gonna guess anything else I need to do before we do this?
Pray.
What? Pray? Prototype, right?
Right.
Right. Good call. Oh, and Spencer, you were asking about running things.
Yeah.
So also, the ampersand, and so when we run our program, it gives us a output and error code. And so if you do the ampersand between a bunch of commands you want to run, it'll stop at the one that failed, basically. So it won't run the rest of them. So if this fails, like when I have compile time errors, this will fail, and so then it won't try and run the program. So just a helpful hint there. Okay, so it did stuff. Let's do a print again. All right, so we can see the original one. We had TTAM, and then we did a pop. So let's do several. Let's see if it crashes. Didn't crash.
We're not printing.
We're not printing either, yeah. Now we'll print every time. So we got the mat, MAT, MA, M, and then there's an empty one. Probably we could print off a new line after this. Ooh, a simple way to do that, puts. There we go. Because it automatically puts a new line at the end. It's another way to print stuff, but you can't do parameters, so it'll just print off the string directly. Yeah, so if you don't need modifiers, puts is a simple way to type than printf. Plus it automatically puts a new line Can be good or can be bad. That's what you want. Right? So questions?
How does it move up when we? Can you scroll down the top?
All right, so the minus minus, right, is going to decrement that where the top of our stack is, so it's always going down when we do a pop. Does that make sense? So here we're decrementing top. So remember, initially top was 0. When we did a push, right, it came into our push. It set the thing at 0, and then said top is 1. And then we did another push, and it set the thing and added it, right?
Okay, yeah.
So each time when we decrement, we basically do the operations in the opposite order that we had originally done them.
Now, it does not move the elements in the array up, does it?
Nope.
Okay, it just makes
Right,
the
so-
spot where top was empty.
So if we think of our array, I'll try and draw a picture of it. So at the one point we had M, A, T, T, right? And then when we said pop, we still had all the data there. So actually it still has M, A, T, T, right? Because we didn't actually zero it out. But before, top was here,
We're just changing where top. Okay,
right? And now top is here.
gotcha.
So top indicates the next place that I'm going to add a new element onto my
It's
array.
different than popping with a linked list.
Yeah, because there you would actually remove it.
Which do you? Yeah, okay.
Mhm. Yep. So yeah, and when I'm all done, it still has, like, it's there, and then we have it points here, and then the last one it's pointing here, right? It's pointing to 0. So logically, it's gone, but the data is still there, right? So the easy way to see that, I can show you this. Right, so I just changed my top variable. When you look, right, all my data is still there. Logically, I've gotten rid of it, but technically, it's still there. So I could do like a, let me see, I do a pop. Right? So I pushed on an H. I didn't print it after I pushed it on, right? Then did a pop. And so you can see that H, even though I popped it off, right? That H is there. It changed the data. Okay? Any questions? Okay, we'll do one more thing here. I think I got a little time. So let's define a return type so that we can safely return and then check our result to see instead of just assuming that value was okay. So we'll just define another struct. So here we're going to change when we do a pop, instead of returning that, we're going to return a result. So now I have a result. And then here I want to allocate it. Oh. Okay, so instead of just saying bad stuff, what should I do here? result arrow OK equals false. And then here, we want to say, or here this isn't result, it's result arrow value, and result arrow OK equals true. All right, so now when we check, we aren't assuming, so, and this happens a lot, right? So the return value of something, you use a special case to say something is good or bad. So for example, when your program runs and exits, if it's 0, it means the program ran fine. If it's a negative number, it means there was an error, and then you go and look up what the error code is. So that's how the ampersand works, right? It checks to see if it's equal to 0. If it is, it'll do the next thing, right? So we're just relying on sort of hard-coded values and saying, well, a program can never actually return the result 0, which isn't always true, right? Maybe you had a calculator. It did a bunch of calculations, and then the value of it was negative 10, right? Having that be an error message is like, well, that doesn't make any sense, right? So this is sort of a better way to resolve that. And then here, instead of char x, I'd have to have what? Result pointer x, right? Because I have to have a match. And then if I wanted to print this off, I'd have to say x arrow value, and I'd have to check my result saying result arrow OK. So if it's true, then okay, it's fine. And if it's false, right, then something bad happened. And I broke stuff. Oh, did I not change this? This needs to be a result pointer. See, Java, you don't have to put all these pesky asterisks all over the place. There we go. Right, so some of those we would get back an error saying, right? If I checked, I believe this one. I don't know what the modifier for booleans is. I'm going to guess a B. Oh, X arrow OK. See if that works. B is not it. I don't want Objective-C. No. It's a %D, which is like, oh. We'll actually see. Okay, so it's 0 there. Let's print it off. So do a pop, print it off there. Yeah, so 1 is true, 0 is false, right? So when we're at C, we don't think about things in types. So you have to compare it to 1 and compare it to 0, which you can use the constants true and false to do that. So if it's equal to true or if it's equal to false. Right? So 1 is a T, I popped off a T. Right? Make sense? Uh-huh. All right. So, no questions? All right, so in the book, let's see. I thought I had a bookmark for this. No. No. I'll look it up. I rebooted my computer, so all my tabs disappeared. I hate it when that happens. What? I know. I have lots of important things that I need to remember. Oh.
It's Canvas. What was that name of the website?
Well, so there's the Canvas one, which allows you guys to save stuff, but there's also another one that's, dang it. Anyway, read the next chapter, the one after stacks, right? So, we're going to, so we'll have a programming assignment coming up here, so I'll try and get that out on Wednesday. So, having you guys implement something in C related to stacks, right? So I'll give you a particular type of stack, have you implement a program that does something related to that. A little computation, a little error checking, right? So not completely crazy stuff, but you have to implement it yourself. I will find the book because it was open. I had it. It's gone. I don't think it's this one. I don't like this. Okay, let's look. Before I go, and this where I go, modules. This is the things. Stacks. Oh, we're getting to binary sheets next. We're still in chapter 5? Yeah? Array-based stacks. Linked-based stacks, right? So, probably read the next 2 or 3 chapters. All right, they're not really long, but, and I'll give a couple assignments. So, all right.